Hi, everybody. If I could go ahead and ask our panelists to come on up. And while they're on their way up, the show of applause was pretty interesting because it seems like the room is pretty split, maybe a bit of a bias toward the software side. And so what we're going to focus on in this conversation is there's been a lot of conversation throughout the morning and then, of course, in Mike's remarks about hyper-converged infrastructure. And so what we wanted to do is kind of take that term apart, talk a little bit about how QCT's partners are working with QCT, how they're working together to address this growing market, what they see from talking to customers about needs and requirements. But before we dive into all that, let's get everybody introduced. Take a minute, introduce yourself to the audience, and maybe take a minute to talk about how you're working with QCT.
Great. So I'm Hal Woods. I'm the Vice President and Chief Architect at HGST. I guide the investments and architectures across the range of our portfolio, all of the high performance as well as the high capacity products. I came to HGST relatively recently after spending 16 years at Hewlett-Packard, the last 10 of which I was designing converged infrastructure. And what I came to realize in that endeavor was there's a certain set of companies who are going to lead the transformation. And it's companies like HGST and QCT who have a unique opportunity to do that. And we're working closely with QCT in our device technologies and in our systems to bring that transformation to the cloud environment.
Great. So I'm Kevin Deerling. I'm the VP of Marketing with MLNX Technologies. First of all, I want to congratulate Mike and the QCT team here. This is a fantastic event. The Solutions Center is fantastic. Looking out here and all of the partners from QCT, but also from MLNX, we see lots of software partners. I was looking out at all the different hardware vendors and storage vendors. We're a networking company. We provide infrastructure for high performance Ethernet and InfiniBand networks and cables. And so all of these things need to be connected up with very high performance networks. QCT is really a great example. We've got a lot of different platforms out there and even examples of both converged and hyper-converged infrastructure that's based on the QCT hardware. And of course, you need to pull it all together with software, hardware, memory, and all the different pieces. So looking forward to talking about that. And it's a great opportunity for QCT to show customers how to build those things here.
Okay, great. Tom Eby, I'm Vice President and General Manager of the Compute and Networking Business Unit at Micron Technologies. And Mike, again, thank you for the invitation and congratulations on the opening. Together with a colleague, Darren Thomas, that runs our storage business, we work closely with QCT on both the near-term mainstream server DRAM as well as storage technologies. And also look forward to a future in which we'll start to see memory move towards a more persistent technology. And certainly the first step there is something called NVDIMM. And that's something that, from a performance and workload perspective, is going to enable bringing some workloads that require that persistence and bringing with it the performance that's typically been reserved for DRAM. So that's just one example. As Kevin said, it's great to see all the partners here. Certainly the opportunity to understand, using an example like NVDIMM, how we can best leverage that technology with the software partners in the room is a way we can further advance and speed to market new technologies. Again, working with this great technology center here that's opening today.
Hi, my name is Brett Pemble. I'm with Seagate Technologies, and I am Vice President and General Manager of the SSD business within Seagate. As such, I'm responsible for all the flash-based products within Seagate in all form factors, from PCIe add-in cards to standard drive form factor and M.2 products, including all protocols from SATA, SAS, and NVMe. As a little bit of history, Seagate has enjoyed a long decade plus working with Quanta, delivering products and solutions to all areas of the market, including the cloud spaces. We're looking to continue to grow that as we broaden our portfolio and SSDs and flash. And thank you for the great opportunity to be up here on the panel, and very excited about the opening of this data center, and excited to kind of re-meet with a bunch of old friends that had a lot of history with. So.
Hi, Yoichiro Tanaka from Toshiba. I'm a flash storage technology vice president. I came from Tokyo, millions of miles away from And we're very much excited to be a part of this big grand opening. And I'd like to say the congratulations to great inauguration of a great entity in the beautiful facilities here. So I'm with the background of storage technologies and increasing the density in higher density products, including the hard drive and the combination of the NAND hard drive as a hybrid drive. And now recently more leaning toward for the enterprise solutions with storage technologies and hard drive as well as a solid state drive. And we are heavily investing the newer memory as MRAM that'll be coming in years. And so that'll be a great impact to the solutions from QCT. That'll be an opportunity of both of us, you and us, to create another new world of the market. Thank you very much again to be part of this ceremony. Thank you.
Hi, everyone. Good afternoon. My name is James Sao. I'm the Engineering Vice President of Quanta CCBU Cloud Computing Business Unit.
Great, and we're going to hear a little bit more from James a little bit later, so thanks for joining us on the stage. So as a lot of times happens in IT, and certainly it's the case in cloud, a lot of times terms get used interchangeably with other terms, and terms get conflated, and sometimes it's hard to sort out the definitions of things. And just as a level set, I wanted to start by talking about converged infrastructure versus hyper-converged infrastructure, and talk about, is it a meaningful distinction, or is it more of a marketing distinction? Tanaka-san, let's start with you.
Okay, so we're familiar with the converged infrastructure. That was the one set of the servers and storage arrays and networks into the one from the one single entity. That is more solid solutions for the enterprise market as well as data centers. The hyper-converged system is a much more modularized combination and integrated units, a modular. The storage network gets smaller, and the storage combined. That's based on kind of computing on data. That's a very smart system, and it could be very scalable on demand to as time goes. So this is a great feature to expand for the future market.
Great.
Yeah, so from Seagate's perspective, we've had the opportunity to deploy products into all different aspects, from standard deployments to disaggregated, aggregated, converged, and now hyper-converged. So we've got a broad history there from our HDD products and our SSD products. I would say that the view, at least my view, of the difference between converged and hyper-converged kind of centers around, we've all seen the migration from siloed to converged, converged infrastructure, which has solved a significant set of problems, albeit bringing complete solutions, single managed solutions to solve direct application problems in enterprise IT. We've seen the benefits of that, and they definitely solve problems there. I think what we've also seen is the large-scale cloud service providers and the web-scale customers be extremely efficient and effective in very, very large data center deployments, and managing those efficiently and effectively. And at the highest level, my view is hyperscale or hyperconvergence is trying to bring that benefit to the rest of the world. And clearly, there's a lot of moving pieces under there, and there's lots of different implementations for that with respect to optimizing the building block and what that looks like with storage, networking, and compute, virtualization, managed software, which I think there's another panel that's going to talk about the software element for that. So I think clearly that the goal there is to deliver that value, that efficiency, that effectiveness to everyone else in the world. Considering what Seagate, some of the technologies Seagate's bringing to bear with that, I think we've got, I'll just touch on a few of them here, but specifically talking about our very large capacity HDDs using Seagate's SMR technology. I think is one that dramatically increases the capacity available in a per device basis. We also have hybrid technologies that we're bringing to bear across SSDs and HDDs that cover deployments that are all in the drive, but also across large scales of SSDs and HDDs, which with management software that will manage data placement across those two components in large scale deployments. Additionally, optimization on SSDs to enable highly efficient and highly effective all-flash arrays through high performance and low latency products, and also low cost SSDs. NVMe technology is another great example that we're adopting that allows us to deliver not only lower latency and higher performance, but also key technologies like banding that allows us to, the applications to deliver I/O that is tagged so that we can efficiently place it in the right location on the drive. So anyway, we enjoy a lot of experience with Quanta on delivering products. We look forward to a lot more. So
Brett, you said something. Actually, Tom, let me kind of take this in a little bit of a different direction. Is it an oversimplification to look at converged infrastructure as chiefly dealing with hardware-focused solutions, whereas hyper-converged relies much more heavily on the integration of software? Is that an oversimplification, or is that a decent way to look at it?
I think it's decent. I think again, my view is that bringing the software, the next panel is kind of the key panel to deliver the hyperscale capabilities to a hyper-converged infrastructure, but also packaging the hardware. I think what Quanta's done with hardware packaging with respect to delivering it in a very efficient manner that can scale is extremely important, just as well as the software that manages it.
Tom?
Yeah, no, I would add. I think it is both, and I guess I would agree. With the comment, it really is about how do we take the advantages and the economies of scale that the large service providers and web providers can afford on their own, and apply that to the masses, to use that term. With no disrespect to I'm sure many customers in the audience today, and I really do think that's one of the unique advantages that QCT brings, is that they can be that virtual large entity that allows that that application of the economy of scale, and I would say it's both on the hardware side, but also on the software side, particularly with regard to the validation that is required. And so I think from our perspective, as opposed to just having to go in to the largest players, and I apologize as to who it was at the very beginning talking about selling into the large cloud players, and the final bullet was you got to sell it cheap, right? And that's true. We have the opportunity to take that same value proposition. And scale that across a much broader set of customers, and maybe get a little bit more value out of that, and then we can fight over how we split those extra pennies, and that's a very high class fight.
Yeah, and actually it's interesting, Kevin. So you guys sit squarely in the part of the data center that a lot of times is focused on, this is the next place we're going to compress cost out. We're going to use NFV, we're going to use network virtualization technologies. But you guys are bringing a different value proposition around performance and agility. Talk about how you see hyperconvergence and what it does in the network platform.
Sure. So it's interesting, when we look at hyperconvergence versus converged infrastructure, we're already in most of the converged infrastructure, but we're hidden inside. We develop very high-speed networking, and really it's a matter of the fault granularity. Where is it that you're going to do, error correction? Where is it that is it a disk drive that you're going to replace? Are you doing RAID? And it turns out you can do that all inside of a box. And with all of these folks building faster and faster memories and SSDs, it turns out with fast storage, you need fast networks. So people are using very fast networks inside of the converged infrastructure. And if a disk fails, so what? You can fail over, you've got redundant controllers. What hyper-converged infrastructure does, it turns out it's very expensive to make those converged infrastructure platforms. And alluding to the economies of scale here, it turns out if you use QCT platforms and you take industry standard solutions and you do it differently, you change the fault granularity. You say, I'm not worried about that disk drive. I can have a whole rack go down and I can replace it. And so you're really doing this rack scale and even data center scale integration that's happening. And there's a lot of moving pieces to make all of that happen. And it's nice to see folks like Red Hat and Mirantis and the OpenStack guys with Canonical, the Ceph solutions that we're part of. There's all kinds of things today that are building that. And it's very interesting. You're seeing software actually working to be the fault tolerance in a hyperscale infrastructure as opposed to when you're doing converged infrastructure versus hyper-converged. So that's the main difference I see, is really how the software is interacting with the hardware and the networking. And for us, we're happy either way, because they all need high-speed networks.
Yeah, and actually, and thank you, I've got a new term now, fault granularity. I'm gonna use that now. Hal, how about the view from HGST?
I'd encourage a little more expansive view. Oftentimes we think of converged infrastructure as starting with the physical infrastructure and working up. In the early days of converged infrastructure, it was very much the case, right? We built a bunch of hardware and we said, here, run any application you want. The trend towards hyper-converged, I think, really relates to building converged infrastructure for specific applications. If we look out in the lab out there, what we saw was a bunch of racks, but they weren't the same, right? Because the infrastructure was tuned specifically for the application they're running. And so I look at hyper-converged infrastructure as really that infrastructure designed to do that one thing very well. And you save a huge amount of money when you use those resources most efficiently for the application you're running.
So that's actually a good segue to the next question. So if you're let's say a web-first company, you've developed an application, you're supporting one or two or at most a dozen different application stacks, not hundreds, as would be the case with a lot of enterprises. Hyperconvergence makes a lot of sense because you can build an infrastructure that makes sense for the application you're running, and you can optimize to that. And then, yeah, if the rack goes down, it's easy enough to replace it. Certainly, that's the case if you're a service provider too, right? So, but enterprises are a little bit different, and they're supporting lots of different stacks. How do you see? What's the value proposition for an enterprise that has to maybe have a high compute, a high storage, a high network type configurations of hyper-converged infrastructure? Does it work the same way? And whoever wants to jump on that first.
I'll take a stab at it. So if I'm a software as a service company, right, I have a small number of applications that are very well understood. If I'm a platform as a service company, like some of the big cloud customers of QCT, I've got a very, very challenging opportunity because I have to have a very elastic infrastructure. It has to be very flexible to run one application 1 minute and another application another minute. Very, very difficult challenges, and a lot of those challenges are solved with very flexible hardware being orchestrated by very sophisticated software.
And I actually think you'll see a hybrid between different converged and hyper-converged as it scales out. So one of the nice things is if you look at a specific workload, you might have one that, boy, I need a lot of storage here. And I've got a guy that works for me who knows QCT's product line, and I can go ask him, which platform do we need that I can put a lot of drives in? And then he'll go tell me this one. And then we'll have another one that's very compute-centric for that workload. And I do think you'll see a mixture. I don't think there's a one-size-fits-all. And so actually having that breadth of choice is very, very important so that you can build out a heterogeneous environment and then use software. And the software needs to dynamically figure out, oh, here's a bunch of storage that I've scaled across a pool. Here's my compute nodes. And all of those things, automating all of that. Because if you're trying to manually configure it, you don't have a chance at the scale we're talking about here. So we work with the software partners to do that, but it's really important that you have a breadth of a product line that you can customize.
Yeah, I think, I guess my perspective a little bit to that is that certainly as you look at migrating legacy enterprise applications and workloads towards more of this hyper-converged infrastructure, I think there's enormous progress that can be made from a OpEx, CapEx, and management efficiencies. But if it were as simple as simply the ability to migrate them all to a hyperconverged infrastructure, then it would be being done and it would be very simple. And the fact is it's not. And so again, I think that's perhaps a more challenging and complex problem, Mike, for you and your team, because it's going to require more granularity, more specialization. And I think it's probably like the frog that jumps halfway to the pond. We can continue to make progress. I don't think we ever quite get there, as long as you have these legacy applications that large enterprises are critically dependent upon. But boy, we can make a lot of progress.
Yeah, I think I'd add to the point that I think it all depends on the scale of the customer. if you're an extremely large customer, I mean, you mentioned Facebook and the products you supply to them, they can afford to have a installation that is 100% only allocated to one application, and it runs that way, and they just build out rows and rows and rows in their data centers. As you move down in scale, you don't have that flexibility. You've got to have hardware that has the right amount of compute, networking, and storage that can cover more than one application and one infrastructure. And you have to have a software sitting on top of that that allows for you to migrate and manage those various applications either running together or at different times over a given day. I mean, for example, one of the products that we worked on with Quanta was for a financial customer, and in the day, it's 100% VDI. They can completely, after those 8 hours, they completely convert that over to a compute farm. And that's the solution, and it's the exact same hardware. So we had to work on a solution with Quanta that would meet both of those needs. Now, is it 100% optimized for either one of them? No. But it is optimized for both and allows them to leverage that infrastructure and not have to have a completely different set of infrastructure to run the compute and the VDI. I think that's where the dream position is that Quanta is in, working with us to help deliver the products and solutions that will supply products that will meet those needs and allow them to utilize that CapEx, OpEx in a much broader way than they can if they don't have that capability.
Is there a crisp distinction? So when you're solving that engineering problem and trying to create the hardware solution that can do two very different kinds of workloads pretty well or well enough, what's the calculus in terms of deciding, okay, the performance benchmarks we're hitting are acceptable so that the advantage we get from designing one infrastructure actually pays off?
I think this one was pretty straightforward. Their primary infrastructure was VDI. We had to be world class on VDI. We had to be good enough on the rest of the 16 hours of the day to compare that to a completely separate infrastructure that was set up for compute. And so the calculation was on the off hours compared to the infrastructure of setting up a whole nother farm and the software investment needed that they had to make because they built their own software to deliver that, be able to manage that and migrate that over from VDI to that compute farm. So that was focused directly on the secondary aspect and the cost of that.
Okay,
does that make sense?
Yeah, it sounds like you're saying that the portfolio analysis component of this, you have to be honest with yourself and say what's critical, set priorities.
What's good enough, yeah.
Right.
That's our view.
Yeah, looking back at the past, at the history, an enterprise and service provider is a different entity. But now, or coming in the future, it's getting more mixed, migrated into each other. Let's say for a service provider, the part of their business is also closer to the financial situation. So e-commerce is a great example. So that could be the mixture of a well-proven reliability setup and a scalable part of it, which is the part of the hyper-converged system. That could be merged. And the point will be the architecting those infrastructure together under the mixed environment of the market. That's a very interesting situation we are facing in coming years.
So you guys represent organizations that touch lots of different kinds of customers, service providers, and enterprises of lots of different sizes. And you've all been doing this, for the most part, all of you have been doing this for a very long time. What are you hearing from customers today that make you think, wow, we've got to get busy on the engineering side and solve these problems? We don't have the solutions yet, but we can see where the market's going, and as an industry, these are the problems that we need to solve.
So I think one of the things is just the software-defined storage and the software-defined data center. We see that vision. I've talked, VMware was here, and we've seen what they've done with Evo, but really making it scale out has been a challenge. And so I think that from an engineering perspective, just making sure that there are no barriers. The worst thing that you can do for a company that's, Uber was mentioned earlier, you'd hate to all of a sudden say, well, we can't scale anymore. You can't have, 1 million customers, that's your limit. So we have to be able to just keep going just keep going without any limits. And I think that's a challenge that we're all facing, and it involves memory, it involves storage, it involves compute and networking. And so together we have to solve those problems, and a big piece of it is the next panel that's going to talk about software, because sometimes there's limitations, and it's always a leapfrog game. You solve something in the software and you expose something in the hardware. So it could be on the networking side, it could be on the memory bandwidth, it could be on the CPU cycles, and every generation it seems like, oh, well, this is not the problem, and suddenly it is, because the new flash memories and the new types of high-speed memories we're seeing, suddenly the network is becoming the problem again. So you need 100 gig or 40 gig or whatever that number is, 25 gig. So every generation it seems like we create a new problem.
So to reinforce that a little bit, I think if I look at what customers expect, they expect reliability and availability and scalability. All those things are table stakes anymore. What they really value is agility, right? They need to be able to respond very quickly to changes in their business, right? So they can monetize that business very quickly, and it requires all the things you talked about.
Absolutely.
Yeah, and I would say it's just an unending increase in the percentage of players that may have traditionally been in a very conservative, relatively slow-moving enterprise space. That their business is dependent upon, again, that agility. So you look at one of the more traditionally conservative outfits for financial services companies, right? And they were the bread and butter of the legacy big iron servers. And now if you look at what they might be doing in high-speed trading or other areas where the performance of that compute farm will make the difference in success or failure of their business, and so the portion of their business that requires that hyper-converged infrastructure like agility just continues to grow, and so it means that virtually everybody we talk to has at least a piece of their business. Some it's all of their business, but everybody has a piece, and so that just kind of changes the nature of the speed with which we, working with partners like Quanta, need to engage with those guys.
And just kind of a lot of the standard stuff, you just got to turn the crank on, which is supposed to latency, density, capacity, performance, power. Those are all just kind of standard table stakes that we all have to keep working on and bringing down, and cost as well. Some of the challenges that we're looking at and we're monitoring to see where the infrastructure trends is things like providing high capacity, low latency storage, providing that access to a large number of products. I mean, our partners here are working on things like NVMe over Ethernet, which is a technology that we think is going to be critical as some of these infrastructures build out and some of these things mature in the industry. We are definitely looking at that. There's some creative stuff we're working on from a system level latency perspective, both in the host and the software stack that we can do. We can provide visibility into some of the stuff that I talked about NVMe with respect to banding and identifying IOs, so we can place them and make sure they end up in the right tier of storage. Anyway, just lots of little pieces I think that'll come together to provide more improved performance, product, and cost.
Yeah, so having the data in a storage device does not make any money. So the analyzing, the digesting, the real-time feedback to the real market, that makes money. So in that sense, the latency, the turnaround time, this is the most important part. So for the reasons, the high-speed SSD and eliminate the hidden background tasks and transparent to the host, and in the data awareness to handle the data, to master it in the right time, to the right direction, and provide the right answer to it. That is a big task we have to complete as a hardware suppliers.
Great. Well, let's take 30 seconds real quick, and each of you tell us what you've got in demonstration here at the Cloud Solution Center with QCT that folks might want to ask about or take a look at before they head out. Tanaka-san, what's Toshiba doing here?
Okay, so we plot the full lineups from hard drive and enterprise, mission critical drives, and it's similar to the solid state drives from client to enterprise class and plus non-chip. And those are our baseline to support as a face to QCT, and that could contribute to entire data center setups. And plus, we are now approaching to modularized key value store type of modules that could also scalable solutions. And the new proposals, the new architecture to make a small modularized product for QCT, that's complete the setup for the data center in the coming future.
Great. Brett, what are you guys doing?
From Seagate, we're obviously heavy in our core business is HDDs. We're showing the latest capabilities, technologies we have there, plus all of our new SSDs and products that we're delivering. And so, pretty much it.
Tom, quickly.
Great. Yeah, I mean the key engagements obviously mainstream server DRAM at ever increasing densities. SSDs at ever lower latencies, and as I'd mentioned earlier, probably the newest area of non-volatile DIMM to bring the benefits of persistence without sacrificing any performance in memory.
Great. Tom?
So we're very fortunate. We're a partner with QCT for a long time on the OCP platform, so we're in there with the networking, but also with mostly other people here on the stage. So we're doing demos with Red Hat Ceph. We've got demos with Micron HGST. We're actually the networking infrastructure for a whole bunch of different things. So very happy to be here.
Hal, bring us home.
Okay, so the one I'd encourage you to look at is my favorite topic, and that's the Hadoop in big data and analytics, both real-time and batch analytics. Very exciting work, and I know that's going to drive a huge amount of infrastructure for QCT.
Great, thank you. So before the panelists leave the stage, James has a few words for us. I think you've heard a lot of different ideas expressed here about how QCT is working with partners. What's QCT's perspective?
Okay. This is such an exciting panel discussion. I can see this is as a good crash course from the industry's most experienced experts. Their vision of how a future data center will be is brighter than ever. I think we all probably gain so much knowledge from today's topic. Thank you. And at the QCT, I probably spend a couple minutes to introduce more. At QCT, we have I think we have the most complete architecture team for data center, from compute, storage, network switch to whole rack, all under one roof. We also have more than 1,000 engineers worldwide to implement the technology from our partners into real product in the quickest time. This very short turnaround cycle time not only allow our partners, hardware, software partners, new technology, time to market, but also help our data center customer can take advantage of our partners' technology to improve their operation efficiency and, of course, reduce the TCO. I think everybody knows, we have helped revolutionize the hyperscale data center so successful. Example like OpenRack to Facebook, OCS, Open Cloud Server, okay, to Microsoft, and in China, Scopia to Alibaba and Baidu. So those hyperscale data center engineers brainstorming, co-worked with our architects to blueprint their future infrastructure and the products, right? Hardware solution. They also heavily rely on our well-defined design and the validation process to make sure, their products are optimal and reliable. Okay. What's our next step? Like Mike just highlight in his keynote speech. Our next step is to help data center in every scale, not just the hyperscale, to have a smooth ride into the hyper-converged infrastructure. You know, we have a very rich product portfolio, you know, from compute, storage, networking to the rack. Right? So guess, you know, I have 1,000 engineers. How many products my team deliver? How many hardware products? You know, you divide by 10. So it's very logical. It's about 100 hardware products. So we have all different kind of a solution to fit all different kind of you know, hyper-converged infrastructure. So anyway, thank you, you know, for coming out today to join us, enjoy the beautiful California afternoon together. Right? I will be around, so please, you know, feel free to come talk to me. If there is anything you think I will be helpful for. Thank you again.
Let's thank our panelists.